Hi students, in this lecture I am going to discuss problems. So the last class I have discussed question number 8, right? Let us see now the next problem. A particle of mass m and charge q is released at rest from origin where electric and magnetic fields are given by E naught I cap and B naught J cap. What is the equation of the path followed by the particle? So you can see here fields. Electric field along x-axis, magnetic field is along y-axis, right? So we have to get now what is a path equation. Let us see how to start it. So first note down the given data. Electric field it is E naught, direction is positive x-axis I cap, magnetic field is B naught, B naught J cap, and we are releasing a positive charge at origin. So velocity how much? It is equal to 0. Okay. Now see what happens. Since velocity equal to 0, because of magnetic field, no force acts on the charged particle, right? But because of electric field, force acts on the charged particle. So because of this, particle starts moving along x-axis. So once a particle starts moving along x-axis, because of that motion, magnetic field exert a force on the charged particle. See carefully direction of force. F bar equal to Q into V bar cross V bar. So focusing only because of the magnetic field. Because of electric field, particle gains velocity along a positive x-axis. So velocity along x-axis means I cap. Focus direction part, I cap. Magnetic field is now along y-axis. So it is now J cap. So I cross J, it is a K cap. That means because of the magnetic field, force is now along a positive Z axis. That means velocity is having now two components. One is X component because of electric field and other one is Z component. That means I can write V bar as V bar. It is now V bar as Vx I cap plus Vz k cap at one instant. Now focus force acting on the particle. F bar equal to Q into E bar. Q into E bar because of electric field plus Q into V bar cross V bar because of magnetic field. Okay. Now substitute values in this. I am taking Q outside. It is E naught I cap plus in the place of V bar. It is Vx I cap plus Vz k cap cross B bar. B bar is now B naught J cap. Now see calculation part. I cap cross J cap, that is K cap. right? K cap cross J cap, K cap cross J cap. Then see what we get. It is minus I cap, right? That means I can write it as Q into E naught minus E naught minus VZ B naught. It is VZ B naught into I cap, right? Now remaining is Vx B naught I cap cross J cap, that is a K cap, plus Vx B naught. It is now I cap cross J cap, that is a K cap, right? Now in this we can see first one X component of the force, second one Z component of the force. Now we want to find accelerations. X component of acceleration. See how much? Q by M E naught minus VZ B naught. That is X component of acceleration, right? Next, Z component of acceleration. Z component of acceleration is Q by M Vx V naught. Okay. So having here two components for accelerations, that is X and Z components. Now see what we can do here. Let us now differentiate this Ax. Okay. See what we are going to get. D by dt of Ax. D by dt of Ax is Q by M constant derivative of E naught 0. It is a constant, right? B naught is a constant derivative of Vz. That becomes now Az, right? Cross check once. It becomes now Az. That is dVz by dt. So now next step. This is nothing but d square Vx by dt square. Because the acceleration, this is Ax, right? Ax is nothing but dVx by dt. So it is now d square Vx by dt square. That is equal to take minus outside Q V naught upon M, right? Remaining is now dVz by dt. It is dVz by dt. In the place of this, see what we can write. It is Az. Az is now Q by M Vx into B naught. Q by M. That means what we get here? Q by M into B naught. Q by M into B naught. This becomes square. Remaining is what? It is Vx. So in the place of dVz by dt, that is now Z component of acceleration. So writing that value Q by M B naught into Vx. Q by M B naught into Vx. Right? And see carefully, this is just like this is now d square Vx by dt square equal to minus omega square into Vx, right? That means here x component of velocity is changing simple harmonically. Students, if you remember, this is which form? D square Vx by dt square plus omega square Vx equal to 0, right? That means here what we can say? Vx is executing simple harmonic motion. Okay. So here we got result that x component of velocity is changing simple harmonically. Then we can write Vx equal to, see what I can do here, Vx equal to A into sine omega t plus 5. And remember here A means A is amplitude. So here this is velocity amplitude, or I can say amplitude of x component of velocity. I am repeating. Here A stands for amplitude of x component of velocity. Its meaning is what is the maximum value of x component of velocity. A simple language. If sine function is 1, if sine function is 1, Vx equal to A. That means maximum value of Vx is A, right? So A is known as amplitude. Amplitude means maximum. It is now x component of, sorry, amplitude of x component of velocity. Now in this A is unknown, phi also unknown. Because coming to omega, it is known, right? What is omega value? Omega square. Omega value q b naught by m. So omega is known. So phi is unknown and A is unknown. Now see what we can write. Okay, let us see. When t equal to 0, what is Vx? When t equal to 0. You can see here, particle is released from rest at origin at t equal to 0. That means t equal to 0, at t equal to 0, Vx equal to 0. That implies, t0 remaining is what? Sine phi, right? Sine phi equal to 0. That implies phi equal to 0. See carefully once again. At time t equal to 0, Vx was 0 because particle was having no velocity. So phi equal to 0, t0. Next, now we want to find out what is a value. Okay, what is a value? Now what I'm doing is at t equal to 0, what is x component of acceleration? Okay, let me differentiate this. Differentiating this Vx, what we get? Ax equal to, we get, it is A omega cos omega t because of phi value 0. At t equal to 0, Ax value, come here. Ax value. What is z component of velocity? That is 0. Because initially particle was having no velocity. So Vz value 0. Vz 0. So this is 0. So Ax equal to Q E naught by M. So I'm writing here Q E naught by M. That is Ax. That should be equal to A omega because T0 cos omega t value 1 and omega value is now how much? Q B naught by M. You can see here this is nothing but minus omega square into Vx. So from this see the value of A Q by M gets cancelled. So from this A equal to, it is E naught. It is E naught by V naught, right? That means now we got the value of Vx. That Vx how much? Vx equal to A value E naught by B naught. Okay. E naught by B naught sine omega t. It is E naught by B naught sine omega t. Let us take this is equation 1. In equation 1, we got A value and phi value, right? So take it as equation 2. This is Vx. Now focus how to get Vz value. Okay. Now see carefully. Getting the value of Vz. See where is Az. This is now Az, right? Az equal to Q by M Vx B naught. So I am writing here from that Vz. That is now d Vz by dt. That is equal to Q by M Vx B naught, right? Okay, now simplify this. So here what we can do is in the place of Vx, substitute now that value. Let me take it as it is now dVz is equal to Q by M into B naught. In the place of Vx, it is E naught by B naught sine omega t dt. Okay. Now integrate. Say B naught gets cancelled. Vz, because time t0, Vz0. At time t, it is Vz. Vz equal to Q by M, take outside. Q E naught by M, taking outside. Remaining is now integration of sine omega t dt. It is sine omega t dt. That becomes now minus cos omega t by omega, right? So I'm taking omega outside. Now take limits 0 to t. Then see what we get. It is now 1 minus cos omega t. See carefully, integration of sin omega t dt. That is minus cos omega t by omega. I have taken omega outside. They are having minus, right? Then see what we get. Cos 0, 1, cos t, cos omega t. This is now Vz. Okay. It is now Vz. So we got now Vx and Vz. Now from Vx, I can calculate Ax, right? See here, Ax value, sorry. From Vx, I can write X value. Now this can be taken as, let me do calculation separately here only. I am taking from equation 2 in the place of Vx. Dx by dt. Dx by dt equal to E naught by B naught sine omega t. Now integrate. Integration of dx, that is equal to E naught by B naught integration of sine omega t dt. Limits 0 to t. When it is a 0, x is 0 because it is at origin. When it is t, x. So x equal to E naught by B naught integration of sine omega t dt, right? Here we got it. That means again we get 1 minus cos omega t. I am taking omega outside. 1 minus cos omega. So I'm taking directly from here. Integration of sin omega t dt. Finally, what we got? 1 minus cos omega t. So 1 minus cos omega t. Omega outside. This is now x. E naught by omega b naught into 1 minus cos omega t. Next, it is Vz. Now Vz is taken as dz by dt. It is dz by dt. Now that I can take it as dz by dt. Dz by dt. Let us make calculation here. Right. Now coming to from equation 3, I want that in the place of Vz, dz by dz by dt equal to what we got here, q e naught upon omega m into 1 minus cos omega t, right? Now integrate this. Then see what we are going to do after making integration. Right. So dz equal to q e naught by omega m into 1 minus cos omega t into dt. Integration of this one. Again, t equal to 0, z value 0. At time t, it is now z, which we have to calculate. So z equal to how much we get? So z equal to, this is 1 minus cos omega t. It becomes t, right? T minus, I'm taking q e naught by omega m outside. Remaining is now t minus sine omega t by omega. Now take limits 0 to t. Say calculation what we are going to get. So coming to the calculation part, right? Q E naught by m, take omega outside, omega square. It is omega t minus sine omega t. So suppose this is x, equation 4. Okay. Equation 4, this is equation 5. Now in the place of omega square, see what I can write? Omega square means omega square how much? Q b naught by m whole square, right? It is d square vx by dt is equal to minus omega square into vx, omega square. Now substitute that value here, okay? Then see what we get, q square b naught square by m square, right? That means we are going to get here, finally, it is E naught by omega b naught into omega t minus sine omega t. Okay. See carefully once from where we started. From equation to right. From equation to what we have here, q e naught by omega m. Now Vz taken as dz by dt. Then remaining calculation part. So finally we got z equal to e naught by omega b naught omega t minus sin omega t. Let us take this as equation 6. Now if you remember equation 4 and equation 6, these are equations for cycloid. While discussing rotation, there we have discussed that when a body is rolling, if you take a point on circumference, path of that point is cycloid. This is what we have learned in rotation. I am repeating. Imagine a ring is rolling. Take one point on the circumference. So path of this point is cycloid. And for the cycloid, equations are given by equation 6 and equation 4. I'm drawing diagram for that cycloid. So this is now x, because x is now, see what is the maximum value of x. When cos omega t becomes minus 1, minus of minus plus 2 e naught by omega b naught. Okay. So path will be, first of all, I'm taking just imagine one ring. Okay. A ring like this. Then we can see now this is 2 e naught by omega b naught. This is x and this is z. Okay. Because for x there is upper limit, that is 2 e naught by omega b naught. That is a maximum value of x. So here equation is now path will be, it is not exact look like this. Okay. This is known as cycloid. So what is this? If you imagine a ring which is rolling, and if you are taking a point on circumference, path of that point is called cycloid. And for that equations are given by 4 and 6, x and z coordinates. Okay. That means when you are taking electric and magnetic fields which are mutually perpendicular, and if we release a particle, if we release a particle, then its path will be cycloid. So this is what we have to keep in mind. Right? I hope you got that clarity. So main thing is it is the calculation part, how we are arriving at Vx, Vz. Next from there, x and z. From equations, we can decide shape of the path, right?